right, it's 9 a.m. So I wanted to say welcome everyone to the second Bluesky Community Voices Twitter space on decentralized storage today. I'm Jay. I'm project lead of Bluesky, a decentralized social initiative funded by Twitter that runs this Twitter account. The Bluesky community is the outgrowth of a matrix group that Twitter brought together in 2020 to talk about decentralized social protocols. And today it's grown to a large public community forum for discussion and debate of all sorts of important topics relevant to the space. And with that, I'll turn it over to Manasi, our moderator for today.
Thank you so much, Jay, for hosting. Before we jump into today's discussion, I know Robert and Golda had some announcements around community voices that they've been planning.
Thanks, Manasi. This is Robert Schwentker, and Golda Velez and I have been helping to organize this community. We have several other Voices events in planning for next year, including topics around reputation and moderation, as well as interoperability, sharing one's social graph, as well as governance and legal. Also at 10 a.m. today, stay tuned for the Q&A. Please get your questions lined up, and we'll attempt to fit in as many people who have questions as possible. Thanks, Manasi. I'll turn it back to you.
Awesome. Thank you, Robert. For those of you who might be joining Bluesky's Twitter Spaces for the first time, it's an amazing series that talks through the different critical infrastructure that's needed to build this decentralized social media protocol. And today specifically, we are talking about decentralized storage and how that plays in the context of social media. What are the trade-offs? How does it work? And what are the implications for end users? I will pass it on to Erin, who is kindly offered to frame our conversation today before we introduce the rest of our speakers. Erin, if you want to quickly introduce yourself and frame today's session, that would be great.
Hi, I'm Erin Goldman. I'm a security engineer at Twitter, and I've been working in distributed systems for years. So I thought I could give a bit of an introduction to sort of a history of distributed storage and centralized storage and the way this has oscillated over the past. I like to start by asking people to consider some of the services that have data about you. If someone like Gmail were to close their doors tomorrow, how much would that disrupt your life? Do you feel like you could get all of the data that you need out of that service? And could you still have it and make it useful? Many services have distributed protocols. Email, SMTP, is a distributed protocol and is relatively easy to use and understood, but it would still be difficult for us to get a lot of our information out of these centralized services. Something like Git is easier. You can switch from GitHub to GitLab by just downloading your repository and uploading it somewhere else and telling people new places to find it. And then we've got things like web search and maps. I get really useful search results out of maps because it knows my location history and places I've been in the past. Even if I can download that data, I have no good way to upload it to any other kind of mapping software. And this history has oscillated in the past. In the beginning of early computers, they were all isolated because they had to be, because there just weren't that many computers in the world. We then got to mainframes where we connected computers and had lots of people time sharing, and we really got networks, but you didn't control your storage because your storage was on the mainframe. Bill Gates really saw his vision completed of a computer on every desk, and people started saving their files on their computer in Microsoft Word, and it became difficult for us to move data between. How do you actually get your Word file to somebody else? Passing around floppies in SneakerNet. And now we live in a world that matches Sun's vision of the network is the computer. Most of us have moved most of our storage into things like Drive or Dropbox, and using services like Google Docs. In the days of Microsoft Word, if one person wanted to switch to OpenOffice, they could, and they didn't have to get all of their friends to move. But if you want to move from Facebook to a competitor, you have to convince your entire social network to move because it's one ecosystem. But we don't want to give up the powers that we get from using these data centers. If you do your storage in the data center, it is 1,000,000 times bigger and 1,000 times cheaper than if you try to store that content on your own computer. So the question is, can we do something with distributed storage where we can get the best of both worlds and really get all of the leverage that we want out of having a cloud and a data center that gives us a lot of power and a lot of leverage, while at the same time giving people as easy an ability to switch to something new as like switching from Word to OpenOffice. You can keep all of your files. All of your Word docs are still docs, even if you stop using Word. Whereas all of your Google Drive docs cease to be accessible if you decide you're not interested in Google Drive. How are you going to migrate all of those docs? With most people doing things like falling back to, well, download them all as Word docs in the older formats. So I'm looking forward to a discussion with a number of people here where we can really cover, okay, what are some ways we can do distributed storage and manage to empower individuals to own their own data and have the ability to migrate to the services where they want to be and where they feel most respected, while at the same time not having to give up all the benefits we get from using these clouds and data centers that are greener ways to do processing and cheaper ways to do processing and really do give us a lot of value because we have access to data centers. Thank you.
Thank you, Erin. I love the point about how we traded off as we move from storing data ourselves to storing data in the cloud. There are trade-offs there where on one hand, we got really cheap and scalable data storage capabilities, but on the other hand, we traded ownership of that data and control over that data. And we will be talking a lot more about, how that works in the decentralized world. But before we jump in, would love for all of our speakers to introduce themselves in quick, like 15-second introduction. And I can go first. And my name is Manasi Vora. I am VP of Strategy and Operations at Skynet Labs. Skynet Labs is a decentralized storage and web hosting protocol that we've built. I'm also the founder of Women in Blockchain, which is a nonprofit to increase diversity in the crypto space, and most recently founded Komorevi Collective, which is an investment DAO. I will pass it on to Paul.
Hey everybody, my name is Paul Frazee. I was one of the co-founders of Secure Scuttlebutt. After that, I worked on a project called the Beaker Browser, which is a peer-to-peer web browser. I've had a lot of experience, especially with peer-to-peer systems, the Hypercore protocol, the tech that I use now, which used to be known as the DAT protocol. It's kind of similar to IPFS, if you're familiar with that. And happy to be here and talk about some decentralized storage, and I'll pass it on to Mark.
Hey everyone, I'm Mark Nadal, and I'm the founder of Gun, which is a database more than a storage system, but of course we do storage as well. It's meant for smaller pieces of data like tweets or GPS coordinates that update in real time, and we got about 50 million monthly active users on our protocol. So really excited to chat about scaling decentralized storage. I'll pass it on to Sebastian.
Stephen Allen, please go ahead.
Steven, I apologize.
Hi, I'm Steven. I work at Protocol Labs. In the past, I worked on IPFS. At the moment, I'm working on just about everything. But here representing IPFS. IPFS is, I guess we call it a decentralized file system. Really, it's a decentralized data transport and data addressing system. Yeah, I'll pass it on to Mikhail.
Hello, my name is Mikhail. I work at Google as a software engineer at payments risk team. Previously, also payment risk team, anti-fraud at Postmates.
Amazing. I think we got everyone. Before we dive into the technicals of how decentralized storage works and how it impacts kind of the end user experience, let's just set the context. What is decentralized storage? And how does it compare against today's centralized storage in terms of some of the key pitfalls that centralized storage that Erin already mentioned?
I think we may have actually missed Ian in the introductions.
Oh, my bad. I think he got kicked out as a speaker. Let me try to add him. But as we wait for Ian to jump in, I think he's still having issues.
G'day, I'm Ian. I'm the
Someone wants
founder of Peergos, which is a privacy-focused
Oh.
peer-to-peer file system. Let's get back to the main chat.
All right, we got everyone now. Yeah, does someone want to tackle the big question of what is decentralized storage and how it compares against today's centralized storage?
Sure, I'll jump in on that. It's going to depend a little bit based on how you're going at it. Generally speaking, usually what we're talking about is the ability for the data to move from one provider or one host or device to another one without disrupting that data and making that transition as smooth as possible. So the simplest example would be what the example mentioned earlier with Git, right? Because with Git, you can move it from GitLab to GitHub, and it's pretty straightforward. You're not struggling to make that happen. A kind of a weaker example is like whenever you're able to do data exports out of a social media service like Twitter or Facebook, which is, it's good that you can get that data, but there's a good term for that called dead data. Once you get it in that form, it's just kind of a capture of it. It's not really easy to work with. So it's definitely better whenever you can do something like Git, where it's all kind of stays alive and you're just changing out where it's staying. And then, you can add in stuff on top of that, like, hey, can I move it from one host to another without changing the identifier for it? So that maybe it has the same URL, even though we've changed the provider. And then on top of that, some of these projects even get in this kind of an automated network for keeping the data online, where you could put in a pot of money, cryptocurrencies or something like that, and then the network will automatically keep it all online. So these are the kinds of, it's almost like a stacking set of features that you can add on to kind of increase really how convenient it is to have your data live independently of any in particular provider, going, again, all the way at the bottom with the exports, all the way to the top where, hey, you put in some money and it just magically stays alive. So that would be the overview I'd start with there.
Yeah, I think that stacking part is really important because like at the bottom layer, you have data portability where you can move your data. And then at the top layer, you basically have interoperable protocols where you can just pick your storage host. And as long as they support protocol you support, you can store your data there.
Yeah, I also want to remark that geography and backdoor access is a really important two properties of thinking about whether something is decentralized. If we look at Google, Facebook, existing large storage providers, they actually are distributed in the sense that your data is replicated across different geographies. Your data is available on many different machines around the world. But we don't call this decentralized, even though it's technically distributed, because the gatekeeper or the access to it has to go through a single entity. So while technologically, pretty much all services are geographically distributed, we don't classify this as being decentralized because of the gatekeeper to that distributed data. The second property is this backdoor access. Google, Facebook, any other provider is able to look at that data on their servers. But there is a simple trick that you can use to quasi-decentralize your own data with existing centralized servers. It's to take your data and encrypt it to make it private before you upload it to multiple different providers, even if they're centralized. And that's not quite going to be the discussion that we're having today, but this is a useful hack for how you can start having some guarantees of decentralized secure storage where even backdoor access cannot get at your information. So if you encrypt your data and you upload it to Dropbox, Google Drive, and a couple of different sources, you have very high guarantees of your data being available in different geographical locations and not being destroyed in some accident or disaster. And you also have the guarantee that since your data is encrypted, they cannot get backdoor access to the meaning of that information.
Yeah, and I think this is more relevant, especially early this week. We saw how AWS outages brought down some of our favorite websites and major applications. And even I think today morning it happened again. One thing that resonates for me is also talking about ownership. Content that we produce right now in the Web2 world, all our tweets, all of the stuff that we post on YouTube doesn't really isn't really in our control, or we aren't the true owners of it, and which is something I see as a trend in Web3 is instead of having these big tech giants be the owner of our data, the ownership model moves to individuals who are truly producing this data. With that, I think I'm going to move into some of the technicals around how does decentralized storage actually work. And one of the big questions that keeps coming up is, how does pinning work, and who decides what kind of data gets saved, what kind of data gets deleted?
This is all going to depend so much on the different projects and how they attack this. Should the speakers, should we all kind of talk about the technologies we know and frame it from that perspective? So here's how this one works and here's how that one works.
Agree. Mark, do you want to take this one?
Sure, I can start. So in the case of Gun, our decentralized database, all the data by default is stored in your browser because that's the easiest access point for creating and starting the decentralized web. It's very hard to get users to download and adopt, to download something if they're not already trusting the application. So everything gets stored in the browsers, and then the browsers themselves, while they're online, host and serve the data based off of a request. So if I ask for my data under a public key, but let's not get into what public keys are quite yet. Imagine it's just my name, Mark Nadal. A request for Mark Nadal will go out into the network, and the network is composed of many different machines. Those can be browsers, those can be programs running on your computer at home, or they might be a program running on an existing cloud that runs the same decentralized protocol as the browsers and the program on your home computer. They're all part of the same network if they connect to each other. Once they connect to each other and that request goes out, an algorithm called a radix tree is used, and that can be thought of as being a prefix. So my name is prefixed by Mars, as in the planet, M-A-R, Mar. So Mark is prefixed by Mar. That prefix is used as a routing key, as a coordinating key, to then forward or relay requests to other browsers, other peers, other machines that also are listening or wanting that same data. Eventually, one of those browsers, my browser, if I'm online, has that data and it receives the full request for Mark Nadal, and it creates a match against what it has in storage. It says, hey, I have this data, and then it takes that data and from the browser replies back over the network to the person who originally requested it. And the nice thing is that the response request is very optimized because you keep track of the previous peer that sent you the original question. So that way when you reply, you have a direct line going back to the original listener. So hopefully that was a very low-level explanation, but also a high-level explanation of who stores what based off of what data they're interested in and what data they ask about in the network.
Yeah, and I agree. It depends on the protocol that you're using. Everyone has different models of how storing data works. But one question, and I know, Stephen, you might have some opinions here, that a lot of users keep coming back to is how does secure delete work? In a world where data is decentralized, there isn't really a single entity controlling or managing that data. What does the future look like if everything's truly decentralized? Does no data ever get deleted?
So I think that actually Mark had a good point here, where like at least in IPFS, you're basically the data starts out on your node, and people only get the data if they ask for it. The next step there is to add permissions so people can't actually get the data unless they have permission to read it, or you encrypt the data so they can't read it otherwise. In terms of actually securely deleting data, that's not actually possible right now. Basically, that hasn't been possible since digital storage became a thing. Because like anyone can screenshot something, can copy something. It's just there's no way to actually guarantee that data is no longer there. Decentralized systems make this a bit more difficult because people may be using their own applications that make it easier to record things or easier to copy things. On the other hand, if you're not shoving your data up to some centralized server, you can at least talk with your friends and say, hey, friends, could you delete this thing? And if you all kind of come together and agree to delete it, then you can actually be pretty sure that it's deleted because there is no centralized server that's just hanging on to a copy.
There's an interesting thing that comes up whenever you talk about that, though. So the idea of saying hey, please delete this thing in particular. The other stuff I deleted it, but it's not a big deal. But this one I really want deleted. There's something called the Streisand Effect, which is where when you sort of indicate that you want something to be removed, then it gets more attention than if you had just said nothing at all. And so sometimes whenever this comes up every time the secure delete comes into play. If you do anything special to indicate, I really want this to be gone, and then please everybody respect that, you may just bring more attention to it. So it's a little challenging.
What is another interesting factoid is a lot of decentralized protocols use what's called the log approach for changing data. And that means every version of every edit is kept in order to put that together. There are a few protocols that actually update the data directly in place. And that's very hard to do in a decentralized network because you have to coordinate what is the correct piece of data. But there is a really incredible academic and developer called Martin Kleppmann who works on these algorithms, and they are generally called CRDTs, conflict-free replicated data types. If you use some of these CRDTs, every single time you update a piece of data, it actually wipes out and deletes the old data and replaces those bytes with the new data. And that makes it much easier to coordinate doing secure deletes in a decentralized network. Because when you go to delete something, it's deleted all historical pointers or references to it, versus most systems that might only delete the latest version of the data.
Actually, I think most CRDTs have to be implemented with logs as well, but they can't be snapshotted. So at some point, you can get to a point where everyone agrees on the current state, then you can delete the history. But until that point, you actually do need to keep the history because that's how you do the merging, where you basically say, okay, let's replay the log from wherever we disagreed. But what you can also do in many cases is you can go back and just not serve the data that's in a log. So if you have basically a log of events that points to a set of operations, you can just not serve one of those operations as long as the data set can still be understood without that one operation in it. So if everyone's kind of moved on past there, that's a way to do delete. It's still pretty hard.
So the log-based
approach
is actually a very difficult way to scale a decentralized system. There have been algorithms from the 1970s from Leslie Lampour that figured out how to do deletes without needing to have these logs. And that's actually what I argue is one of the most important technical differentiating factors to how you get a decentralized system to scale, is not using the log-based approach, because storing every version change of every single message in a network that's largely volunteer is extraordinarily difficult, but the algorithms exist to change that for a long time.
I think a lot of it comes down to the fact that a secure delete in a distributed system is a statement of trust. I am saying I am going to contact the people who I know have a copy of this and ask them, I would like you to delete this thing. And I am trusting that they will actually take that action. And this is something that we can't really enforce technologically, but we can enforce with things like contracts or reputation and say, look, I'm only going to share this piece of content with servers that I believe are my friends or with servers that have agreed to some open source terms of service that says, by the way, if I receive one of these tombstone things that says this thing is deleted, within 28 days or 60 days, I'm going to actually delete the object. But it really does require a trust relationship because most deletes in a system like this is going to be a tombstone. I say, hey, this thing that used to exist, consider it deleted. And only when someone is doing a compaction and says, okay, I'm storing this thing and I'm also storing this thing that says the first thing was deleted, they can obliterate each other and then I don't need to store either. That's cheaper for me on a storage perspective and something I may want to do for contractually obligated reasons because I want to do something like comply with the GDPR laws.
Erin, that's an interesting point because a lot of these decentralized storage networks are designed to be trustless in their sort of synchronization design, similar to how BitTorrent is. The whole idea of bandwidth sharing comes from the fact that anybody could show up, fetch the data, and then rehost it. But what you're talking about with these contracts suggests that maybe a reputation layer needs to get involved at the synchronization layer so that we can have things like secure deletes.
I think we can definitely have an entire conversation around secure deletes, and I'm getting a lot of requests to speak. So I'm assuming there are a lot of questions on this, but maybe we can move that to the Q&A section. Again, just a heads up for everyone who's listening, the Q&A will begin in around 30 minutes. So please save your questions for then. I did want to talk a little bit more about how availability and reliability works in a decentralized storage ecosystem. We are really used to the number of nines metric, the uptime that's provided by our centralized storage solutions. Wondering what are the agreements and expectations or people should, I guess, like expect in a decentralized data storage solution. Maybe Steven?
So there are two approaches here, really. One is the market-based approach, and the other is effectively like an auditing-based approach. With the market-based approach, you don't really even set guarantees like this. It just comes down to what you're willing to pay and what makes sense from market incentives. So if you want your data available, you just pay market rates. But this is hard to get guarantees out of. You can get guarantees by basically when you make a deal with someone and get them to store your data, you can have some set of third parties or some third party that both of you trust audit that the data is actually being stored, and then they would be able to fine the person storing your data out of some set aside collateral if they fail to actually meet the uptime requirements. This is opposed to centralized systems where you're kind of just hoping that they will do what they're supposed to. Well, it's not entirely hope, actually. With a centralized system, you have your SLA, and then in theory, you can go to arbitration or court or whatever and say, hey, like we have evidence that this provider didn't meet this SLA. But that's actually kind of expensive and it's really hard to prove things. The nice thing with a centralized system is like, because you actually lack the trust, you have to build better ways to validate that people are actually behaving correctly, which means it's actually easier to prove when someone is misbehaving.
I would love to hear from Mikhail, working at Google, working at one of these like centralized players that we are talking about. Would love to hear his perspective on not just his metrics, but how, what does he think about decentralized storage system scaling for, at this point, if we decentralize Twitter, we are talking, millions of users and potentially billions in the future.
First of all, I want to say that it's very important to keep your data decentralized, to not be owned by private company, especially in recent events when Twitter, Facebook can delete account and person cannot download private data. So when you can keep this data on different nodes, it works much better. In terms of Google, it depends. If you can trust big company, you can have this data own it. But again, it's much better to keep your data in hand and be able to download it.
Another, I think, big topic is, in a decentralized world, how do we think about privacy? Um, Privacy is, might not be critical for some of the public data that we put out, but it's still critical for, example, DMs. I don't want that information in the public domain. I know, Ian, if we have you back here, you had some thoughts on privacy in a decentralized context.
Yeah, so privacy is a super deep topic and a difficult one. And so I think table stakes on this is end-to-end encryption. Then at least you're not worrying about whoever's storing the data reading it. And you can go further and have a lower level of access control as well, so that people can't even retrieve ciphertext without permission. And that those two combined will go a long way to enabling the privacy. And because it's end-to-end encrypted, it's ultimately under the control of the end users themselves, and that's what you really want. You decide who can see your stuff.
Yeah, and I guess taking that further, we spoke a little bit about how decentralized storage systems work. I do want to talk about decentralized storage systems in the context of social media. And I think one big component that's needed when you store this data in a decentralized manner is discovery. How do you discover the content that your friends are posting? How do you potentially do this without needing a centralized index?
If I can jump in really quickly, the radix tree, which uses prefix, is a very easy way to approach this. People have a name, and then they ask for that name in the network, and then various computers all forward and relay that request based off of the prefix tree until they find the data. And then the data itself might have more information about what other records to find that might be more efficient through things called content addressing or hash addressed spaces.
Yeah, discovery I like to think about in the sort of building it up based on scale. If I have one server, I always write to that server, I always read from that server, I always know where my data is, it's on the one server. If I have 5, I now have a choice. I can write my data to one of the servers, but now when I go to read, I have to read all 5 to make sure I find it. Or I can write the data to all 5 of my servers, and then I can read from any one of them and not worry about it because the data is in all of them. Those kinds of strategies might work okay if there's 5 servers. They're not going to work okay if there's 100,000 or 1 million or 1 billion places where it can be. To solve that problem, you have to build an index where most of the servers won't have your data and most data you're not going to write. You have to say, okay, where do I put it? Now, in a centralized system, you simply trust the index, that the index knows where your data is. In a decentralized system, we now need to get into these games of, I don't want one server to own the index because then I'm back to centralized. But if I use something like a distributed hash table, now I have this game of, okay, multiple different parties are each holding pieces of the index, and part of the index I need may be on somebody else's server. How do I trust them? How do I know that they're not going to delete it? How do I know that someone's not going to run a large number of indexing nodes in the hope that they can kill some particular piece of data and filter the data simply by doing a lot of the indexing? So we end up in these games of, okay, how do we build trusted Byzantine fault-tolerant systems where there's always more than one place that each piece of the index is stored and we can still find all of the content?
Yeah, so this has been a constant pain point for IPFS, where we have a DHT and people use it for content routing. But unfortunately, all the DTG servers are not very reliable. So it means people have to constantly, repeatedly tell the entire world where their data is. So that's actually the biggest scaling problem for us, where if you have to announce a trillion pieces of data every day, you're going to die from bandwidth costs. You just can't do that. So this is, at least for us, one of the biggest issues. Like, you need a reliable network for content routing, but you also don't want it to be centralized where one party could just take everything out.
Yeah, scale really is the killer on this one. When you're talking about the kind of scale that we're used to with social networks, especially something like Twitter, where you expect there to be sort of almost like a logical single place that you can get everything, you at some point are just going to run into the challenges of resource constraints, because social networks, as we currently use them and know them, use a ton of computing resources to maintain these indexes and to have them update in a timely fashion. So at some point, you have to address the resource requirement for getting these kind of massive scale indexes, if that's what you're going to try to accomplish. If you're at a slightly smaller scale, the only thing that I've seen to be in some way interesting about dealing with discovery would be what Secure Scuttlebutt did, which is that they used the follow graph and then would automatically synchronize up to some amount of hops out of your graph, and I believe it was about 5. So you would get a lot of people's information. People 5 follows away from you can go pretty far out there, but that tended to get most of your kind of social circle into your local index without getting so big that your personal computer couldn't handle it. So that was maybe one of the more interesting things I've seen. And generally speaking, that's sort of a way of dealing with the spam problem that comes into play when you're trying to have an open network. How do we choose, whenever we're trying to index these things, what gets included? And that's basically using a reputation system.
I actually want to
go.
I want to quickly +1 that. I think Scuttlebutt is really cool, or at least the way they do content discovery. And actually, it solves one of the interesting problems that you have with content discovery and privacy, because one of the biggest problems we run into in IPFS is when you try to find content, you tell the entire network that you're trying to find this content. So while you can have content privacy by encrypting it, getting metadata privacy is really, really hard in a decentralized system. But if you have a system where you just go to your friends, then that really helps you there a lot.
I want to jump in on the first part of the question, because I full-heartedly agree on these parts about friend-to-friend connections. But BitTorrent, I want to remind everyone that BitTorrent scaled up to about 40% of the world's traffic before Google even got to that scale. BitTorrent scaled up to 40% of the world's traffic, and that's on large files like videos and images, not small pieces of data. So we've certainly seen decentralized networks that scale to global sizes before centralized systems do. It's just that this new round of decentralized technology is not necessarily using the same algorithms of older decentralized protocols. And then the last thing that people might jump on me, fairly so, is there's question as to whether BitTorrent's tracker network for finding that data was actually decentralized or not. But I wanted to remind people of BitTorrent.
That's true, but BitTorrent, the amount of data there is still an order to maybe 3 orders of magnitude smaller than something like a Twitter index would look like. The scale is enormous when it comes to these indexes.
I also want to note that it's less about the size of the data and more about the number of pieces. So actually, smaller data is much, much harder for content routing than large files.
I wonder, Ian, if you have any thoughts, particularly on how you are doing indexing with Peergos. Ian, did we lose you again? Okay, looks like it. We can wait for Ian to be back.
Actually, we have someone from Google here, so it'd be quite interesting to ask that question of, the discovery service for Web 2.
Mikhail.
Unfortunately, I cannot help here. I work at payment risk team, so no knowledge about index.
I'm not sure I got that. I think there's some disturbance on your end, Mikhail.
Oh, yeah. I think he mentioned he was on a different team, which was worth a try, but Google's a large company now.
But to some extent, Google is how we answered the question the last time. The internet is a highly distributed place where lots of people run their own web servers and you can go to any page. Why did the internet not fail? And the answer is kind of because a small group of people got together and said, we are going to crawl the entire internet and build an index. And that's where we got Google from, was they solved this problem by introducing a centralized index that the web desperately needed and have gotten a fair amount of value out of being in that position. So if you want something that is a very distributed web-like thing to work, you really do have to solve this question of how do we build a distributed index that can actually be trusted and that different kinds of search engines can all be built off of the same shared distributed index without having to say, okay, every single person who wants to build a search engine, step one, go index the entire web.
I hear Paul Frazee's comment about how to do this. Is the correct way is to actually index based off of your friend of friend web of trust. So great that Paul brought that up earlier.
That's one way, but if you want global search, you still need a global search engine. One, I wonder if anyone's heard of Yasi. It's like a sharded distributed search engine that exists. It's probably the only one I found that exists.
Yeah, basically, Yasi is trying to use a cluster of peers that I don't know how the trust mechanism works there, but whenever you run a query, you're actually going to automatically hit multiple of those different indexes that are in your sort of local group, which seems to be decent. I mean, it sort of reminds me of some of the early attempts to create meta search engines, which it might be interesting to ask why that failed as well, because at the end of the day, you have to run crawlers or indexers somewhere to produce these indexes. Maybe you even distribute them as data sets on top of these data synchronization layers. So is it possible to have a search query do what Yasi is doing, what some of those meta search engines did, which is just to hit multiple of them? And if you get that in at the start, maybe one of them never ends up becoming the big one.
So your browser is really powerful. It's keeping track of every website you've historically visited by just going to your history tab. It's perfectly possible for us to say, hey, I'm going to make a query for some data, and that's going to go into this prefix tree that we talked about before. And that would then check which of my friends might have data that corresponds to that prefix, and then look on their computer in their browser history, let's ignore the privacy implications for a second, to find a matching piece of data and then respond back. I'm trying to make a layman explanation for a complicated concept, but you can take those ideas and accumulate them together in a way that is scalable, because the lookup is what's called O1 across your friends, and then you combine those responses to get your final result, and you then compare those responses for which ones have the highest matching frequency. So a quick example here is Elon Musk. If you search across Bing, Google, DuckDuckGo, Brave Search, and a few others, pretty much 5 out of the 8 search results will give you his Twitter URL as the top hit versus a Wikipedia or a different page. And that can be used as a confidence score to say that this has the highest search value across many different search results.
I think this also leads to the question of, there are different ways, from what I'm understanding, there are different ways to do search and indexing in a decentralized manner. But I think one critical piece in terms of feature that's needed is that all of this has to happen at speed, which we are used to in the centralized world. My tweets load pretty much instantly. When I'm messaging people, it's going instantly. How does that work in terms of speed and time to access in a peer-to-peer setting? And maybe Stephen, if you have thoughts on this.
So I think a lot of this comes down to a trade-off of basically performance versus robustness and centralization versus decentralization. So what you can do here is you can have a system where you optimistically check some federated or reasonably centralized server and say, hey, where's this thing? And if you're in some adversarial situation where they don't give you the answer for whatever reason, legal or bad incentives, then you can go to a more distributed system. So for example, like you could have some recursive resolver that or not even recursive resolver, just like a caching resolver. You can say, hey, like I'm looking for my friend's like file. If they don't know where it is, then you can go like the full DHT and make an expensive query and like try to find the data. And if you can't find it there, then you can just go around and ask every single one of your friends. So I think the trick here is like you start out with something that may not work in all cases, but is really fast. And then you continuously degrade to things that are more likely to work, but are slower and slower and slower.
Ian, are you back? We don't hear you.
Yeah, I think so.
Okay.
Can you hear me?
Go ahead. Yes, we can hear you now.
So yeah, I mean, sorry, back on the discovery problem. I was thinking you can split the problem into two sub-problems, one of which is for public content and one of which is for stuff from your friends. And the idea there is that most people don't have more than, of the order of a few thousand friends or people they're following. And so that's quite feasible for the end client to basically request the latest post from each of your friends. And in the case of public content, then yes, that's essentially infinite. So you do need something to pre-index that. But you can subscribe to different pre-indexes of public content and merge those into your feed client side.
I want to jump in really quickly and say, why is this important? We've talked about some of the algorithms behind indexing, but really, why is it important?
Well, I guess one of the things I would is kind of in agreement with that is that there are multiple different sort of layers or attributes of these networks that we can look at decentralizing or not decentralizing. It would be great to get every one of them, but it may just turn out that search isn't one of them that gets done for it, that we end up having the equivalent of a Google for this new world of data sets. But if you have better data ownership or better confidentiality or et cetera, I'd like to say that at least you're moving the ball down the field, to use a really bad sports metaphor. So this may just be one that we don't crack on this go around.
Switching gears here, and we can come back to the topic of discovery and indexing in the Q&A section. I know we are pretty close to time here, so I wanted to get through a couple other questions I had. One of them is this idea of moderation, and this is a topic that Bluesky community will be hosting later as well, but I briefly want to touch on it. I think a lot of people, when they think of decentralized social media, think that it's going to be a cesspool in a way where people can just post everything and it's going to degrade kind of the quality. But I don't think that's really true. And there are some tools that can be used to kind of moderate and ban people. I'm wondering what are everyone's thoughts here in terms of having an efficient, trusted space based on agreements.
Yeah, there's just no reason why moderation or curation aren't a part of this. The data storage and synchronization layers may be totally unopinionated, but what you end up seeing in your personal experience, there's a number of different schemes that you can use to choose what's going to show up in front of you. It doesn't have to be the kind of thing where if it's put on there, you see it. So this, in practice, really shouldn't be that bad of a challenge.
Agreed.
I would split moderation into two problems. There's the technical, hey, this thing is on a deny list. I don't want to see it because it's on my deny list, whether I'm trying to reject a particular post or everything from a particular user or possibly everything from some big community. The second one, which is much harder, is okay, which things should go on those deny lists? Like, people are able to make toxic content at an incredible rate and make new identities and accounts at an incredible rate. We're always going to find ourselves in this game of you need someone to be the moderation service. And when building a distributed thing like Twitter, you're going to want to be able to subscribe to different services and say, hey, before any piece of content is shown to me, run it through this set of filters and choose who gives you those set of filters. Today on Twitter, the filters you get is Twitter trust and safety. And today on Facebook, the filters you get is Facebook trust and safety. You don't have a choice to say, I wish to use a different trust and safety provider in the centralized platforms. In a decentralized platform, you may have that choice, and there's going to be a bunch of implementations of that, both centralized and decentralized, that you could choose to subscribe from, probably.
I think it's also important to reconsider the defaults. So right now, like, the default is allow, where you can see everything. But in a decentralized system, ideally you have a good reputation system, so you wouldn't just someone wouldn't be able to just create an account and you would see everything they post. Ideally, you'd only see that if that account is somehow linked to you through some set of friends. So basically, there's some reputation behind it. That can just already filter out a lot of the spam. It makes it a lot harder.
Web 2 has actually already done a lot of the research on this. When you look at Twitter's social graph and Facebook's social graph, you get the Kevin Bacon 6 degrees of separation effect. It turns out that 6 degrees of separation is through physical mail forwarding. But when you analyze these networks online, there's higher degrees of clustering. And across both networks, even the Bitcoin network, the researchers have found the average degree of separation is 3.5 degrees to access everybody in the world. And we can use this hard-coded, rough approximation of human population, about 8 billion people, and 3.5 degrees separation online for that, to actually very quickly detect where spam bots, fake accounts come in, because they will exist at 4 degrees or beyond. It's not always perfect, but it's been a very accurate heuristic that multiple different researchers have been able to confirm.
I wonder if Mikhail has any thoughts or wants to share his experience from working at Google on this particular topic.
It's very important to, as Mark said, to be in control on your filters. So when we are talking about information that is stored in decentralized storage, we want to show to customer can see information that he wants to see, not just by privacy or security reasons, but there's a problem when you can subscribe for specific information and be in some kind of echo chamber, and in the decentralized system, it shouldn't be the case like in real social networks.
Yeah, one of the things that we ran into when working on Secure Scuttlebutt, again, in that model, the only information that you received was somehow through this follow graph, and it would go multiple hops out. And you have a weird localized view of what's occurring in the network. And I don't know if this is really a problem, but it's certainly an adjustment for a lot of people. When I'm using Twitter and I look at my follower count or anybody else's follower account, usually I can look at that and say, yeah, that's the total number, right? Because anybody that's on Twitter will probably get listed under that person's number of followers. But if you're applying these local filters to say that this only goes to 5 hops out on my follow graph, you're actually not seeing everything. And if you're seeing somebody for the first time, maybe somebody that's way out on the edge, it would only be able to tell you that they have 2 followers. So that signal, which is something that people use quite a bit when they're evaluating a profile to kind of get a sense of their reputation, ends up being a very different one. And all it can really tell you is something that's relatively personal. Now, if users understand that, it's not a big problem. But if they, it's a little bit of an adjustment if you take that approach.
I think I want to, switch gears again, just because we are running out of time, and talk about end user. We talked a lot about the technology, how it works, some of the challenges and trade-offs that we are making. What are you end users' expectations in terms of user experience that they should be thinking about when eventually we will have these decentralized social media applications at scale? And I guess the second question I want to ask in the same vein is, there are certain things that are not possible in today's web, just because of how it's structured. Are there things that are not possible today that will be possible in this future world where everything's decentralized, from our social media to our storage? Erin, if you want to take a shot at this.
Erin?
Or anyone else, if Erin doesn't want to speak up.
Sorry about that. My main argument for things that can be done in distributed spaces that the centralized people really can't do is that it, in some sense, enables you to be both stricter and more lenient in how you're interacting with things. Someone like a Twitter or a Facebook has to do a least common denominator that is acceptable for 1 billion people. They are unlikely to spend a lot of time launching a feature like, here is our widget for rendering chemical formulas really well in our application. Whereas if you have something that's very decentralized, a very niche community can say, I want to make a new kind of post, and still have that be something that they can do and they can interact on their particular clients. And if it becomes popular, more clients can interact with that. And it just enables you to really keep this, I want to have data that moves around. And because there's lots of different specifications and lots of different schemas for kinds of objects, you might be able to share across different networks, despite the fact that you don't have perfectly identical schemas. Whereas with Twitter or Facebook, they solve the problem by saying everyone gets the same schemas, everyone gets the same feature sets. It's very hard to do sort of small scale labs of how the thing should work because you want to essentially give everyone the same experience.
What Erin is saying has me so excited. There's a couple early previews of this, like maskbook.io, as well as party.lol, which is mine, but I recommend Maskbook. You install a browser extension, and it will detect that you're on Twitter. And if somebody tweets something specific, the browser extension will re-render that tweet as an analogy here, as a song or as a photo. So in the case of Twitter, Maskbook, what it does is you're allowed to take a tweet, and it uses a cryptographic technique called stenography, if I got that correct, which encodes your tweet privately into a photo of a cat. And so the cat photo, it looks like that's what's being shared on Twitter. But if you have the browser extension, it'll actually decode the cat photo into something else. And it's so cool.
The steganography, it's one of the funnest things in computer science. I love steganography. And it's kind of interesting, actually, what that's doing, because one of the really interesting challenges, this is a super interesting space, this idea that development in particular is decentralized and that new features can kind of virally emerge from the user base. But one of the really interesting challenges that immediately shows up is when everybody is free to do their own thing, how do you ensure some kind of shared experience, which is very difficult to solve. Even XMPP, which took a lot of pains to create a registry of each protocol extension that was used inside of it, had trouble agreeing with those standards. And so sometimes you would send text with an attachment like a photo, but it turns out my client uses the other extension for handling those kinds of things, and so you lose shared experience. Very challenging piece of this, but the steganography approach is kind of fun because it's almost like that's encoded a fallback directly into it. So you have an understood baseline that photo is going to show up, but then for people that understand the protocol, it does work.
So actually, I want to note for the shared experience side of things, the advent of things like WASM will hopefully help there a lot. Where now instead of just having to describe data, you can literally ship functionality around with the data, and then have that run in a secure container that people can reasonably trust. Although that runs to other problems where now if you're just executing arbitrary code, obviously you have, we trust that works mostly, but that's a big security concern. But yeah, back to the general problem here, to me, it feels like this is kind of like the resurgence of the desktop, where we live in this world for a long time where kind of you live in these web applications that basically there's only one of them, but now people can go back to choosing their own applications that do what the user wants.
I agree. I think that's what excites me, is that, currently I think in the Web 2 world, it's one size fits all solution. And there isn't really a lot of room in terms of iterating on it and customizing that experience. And I think that is something that a decentralized social media can enable. I know we are at time here. Before we move into the Q&A section, did anyone want to make any closing remarks, either the speakers or Jay at Bluesky?
I'd like to close
sure.
by... Sorry, go ahead.
Oh, okay. I was going to just say it's been a great discussion, and looking forward to continuing everything in the Q&A. We touched on a ton of topics, and there's also going to be a recorded version of this if everyone wants to catch up later. I think there's so much to discuss here that it's more like we opened a kind of conversation starter on each of these topics, but to really get into it would take probably all day.
Love it. Thank you, Jay. Yes, we definitely can get into a lot of the topics that we've started. So we are going to transition into the Q&A section of this Twitter space, which Robert here, I'm going to try and add him back. He's going to moderate that. But in the meantime, if people want to kind of get going and have questions, please request access to speak, and I can start adding you in the space.
Hi, Manasi.
If
Hey,
we
Robert.
could make some closing remarks, it'd be great.
Please, let's go around for closing remarks. Manasi, please go ahead and take that.
Okay, no worries. I wasn't sure if you wanted to be right on time, but yes, Erin, I know you had some closing remarks.
Yeah, I was going to say that there was a time when programmers were very focused on these ideas of you should make a program that does one thing and does it well, and that programs should read and write text streams because this is a universal layer and you could pipe these things together and build more powerful pipelines out of weaker applications. To some extent, we've lost that because we've lost control of our data. And it can be very difficult to pipeline together 3 different web applications that each have their own APIs. If we can move to a more decentralized stored objects and schema-defined objects, we might be able to get a little bit closer to that Unix philosophy as applied not just to one computer, but the entire web, where it really is feasible to make a small program that does a single small feature well and have that interoperate with an ecosystem, as opposed to having a question like, do you want to switch from Twitter to Facebook or Facebook to Twitter? It can be a question of, do you want to add this one tiny piece of functionality to the ecosystem that you're operating in?
For me, and the reason why I started the GUN protocol, is that the internet is our global shared question for truth by humanity. When we have a question about what is real, when we have a question about ideas or thoughts, we want to interact with as many people in the world. And so the internet represents our ability to inquire about truth. If that's controlled by Google, we get a distorted view of what Google's ideology might be. But if we can have a global internet that is decentralized, then our inquiry for truth across all of humanity becomes so much more accurate and reflective of the cultures and the beauty and the art that we have in the world. That's why I care about protecting the internet and moving things forward into decentralization.
I guess I can't really follow that, but my closing remarks would just be that this whole space is a blast, and I'm always happy to talk to anybody. So my DMs are open. Feel free to reach out, anybody in the audience.
Ian, Mikhail, if we still have you both, if you want to step in for any closing remarks. If not, Robert, over to you. We have a few people who've requested to speak and ask questions.
Hi, Manasi. Just a set of announcements, please, as well. Next Friday at this same time, Bluesky Commons will be hosting a Twitter space on blockchain incentivized storage. So please stay tuned for that. Also in January and February, we'll be having other topics like this, such as the moderation and reputation, as well as interoperability and storage graph portability. So with that, we'll take questions. Please keep your questions to under 1 minute. If you'd like to introduce yourself as well, please do so. If you want to direct your question to a specific speaker, please let us know. And speakers will respond to your questions in approximately 1 minute time frame, so we can get as many questions in as possible. Also, if any of the panelists had some closing remarks and would like to make them, please go ahead and do so as well. And so please queue up for questions by requesting to speak, and then we'll add you on to speak. Thank you.